In the last class, we discussed about the definition of alkaloids and properties of alkaloids. Now, we discuss about the classification of alkaloids. In this classification, different classification methods are there. Here mainly discussed about two methods only. First one is general classification method and second one is chemical classification method. Now let us go to the general classification method. On the basis of origin of alkaloids, alkaloids are classified into four types. First one is true alkaloids and second one is proto-alkaloids and third one is pseudo-alkaloids and fourth one is false alkaloids. Let us go to true alkaloids. True alkaloids are defined as alkaloids that are derived from amino acids and have nitrogen in a heterocyclic ring are called as true alkaloids or typical alkaloids. Atropine is taken example to true alkaloids. Second one is proto-alkaloids. Proto-alkaloids are defined as alkaloids that are derived from amino acids and do not have nitrogen in a heterocyclic ring are called as proto-alkaloids. Ephedrine is taken example to proto-alkaloids. Third one is pseudo-alkaloids. Alkaloids that are not derived from amino acids but have nitrogen in a heterocyclic ring are called as pseudo-alkaloids. Caffeine is taken example to pseudo-alkaloids. And fourth one is false alkaloids. False alkaloids are not an alkaloids. It is defined as non-alkaloids give false positive reaction with alkaloidal reagents are called as false alkaloids. Among these four types, true alkaloids and proto-alkaloids are derived from amino acids. On the other hand, pseudo-alkaloids are not derived from amino acids. In true alkaloids and pseudo-alkaloids, nitrogen atom present in a heterocyclic ring. At the same time, in proto-alkaloids, nitrogen atom is not present in a heterocyclic ring. So in general classification method, alkaloids are divided into four types. First one is true alkaloids, second one is proto-alkaloids, third one is pseudo-alkaloids, and fourth one is false alkaloids. Now let us go to the second classification method, that is chemical classification method. Already we know alkaloids containing heterocyclic compounds. Already we know alkaloids containing heterocyclic compounds. On the basis of the heterocyclic compound present in a alkaloid, alkaloids are classified into different types. For example, if an alkaloid containing indole heterocyclic compound, that kind of alkaloids are called as indole alkaloids. If an alkaloid containing indole heterocyclic compound, that kind of alkaloids are called as indole alkaloids. Reserpine and strychnine containing indole heterocyclic compound. So, reserpine and strychnine are taken example to indole alkaloids. Second one is phenanthrene alkaloid. If an alkaloid containing phenanthrene heterocyclic compound, that kind of alkaloids are called as phenanthrene alkaloid. For example, morphine. Morphine alkaloid containing phenanthrene heterocyclic compound. So morphine is taken example to phenanthrene alkaloid. Next one, indolidine alkaloids. Indolidine alkaloids. If an alkaloid containing indolidine heterocyclic compounds, that type of alkaloids are called as indolidine alkaloids. For example, vincristine and vinblastine. Vincristine and vinblastine alkaloids containing indole or indolidine heterocyclic compounds. So, vincristine and vinblastine are taken example to indolidine alkaloids. Next one, propylone alkaloid. If an alkaloid containing propylone heterocyclic ring, that type of alkaloids are called as propylone alkaloid. Calcine is taken example to propylone alkaloid. Next one is quinoline alkaloid. If an alkaloid containing quinoline heterocyclic compound, that type of alkaloids are called as quinoline alkaloids. Camphothicin is taken example to quinoline alkaloids. So in chemical classification method, on the basis of heterocyclic compound present in alkaloid, alkaloids are classified into indole alkaloids, phenanthrene alkaloids, indolidine alkaloids, propylone alkaloids, quinoline alkaloids, and many other. Next topic is chemical tests for alkaloids. We used some reagents to identify alkaloid in the given sample drug. We used some reagents to identify alkaloid in the given sample drug. In these reagents, first one is drag and drops reagent. This test is called as drag and drops test. Potassium bismuth iodide solution is called as drag and drops reagent. Potassium bismuth iodide solution is called as drag and drops reagent. In this test, 1 ml of drug is taken in a test tube and add 1 ml of dragon drops reagent. A reddish brown precipitate is formed. This shows the presence of alkaloid in the sample drug. Second one is Mayer's test. Second one is Mayer's test. Potassium mercuric iodide solution is called as Mayer's reagent. In this test, 1 ml of drug extract is taken in a test tube and add 1 ml of Mayer's reagent. Whitish or cream colored precipitate is formed. This shows the presence of alkaloid in a sample drug extract. Next one is Hager's test. Hager's test. Saturated aqueous solution of picric acid is called as Hager's reagent. Saturated aqueous solution of picric acid is called as Hager's reagent. In this test, 1 ml of drug extract is taken in a test tube and add 3 ml of Hager's reagent. Yellow colored precipitate is formed. This shows the presence of alkaloid in a drug extract. Next one is Wagner's test. Iodine potassium iodide solution is called as Wagner's reagent. Iodine potassium iodide solution is called as Wagner's reagent. In this test, drug extract is taken in a test tube and add Wagner's reagent. Brown or reddish brown color precipitate is formed. This shows the presence of alkaloid in a drug extract. And last one is tannic acid test. In this test, 5% tannic acid solution is added to drug extract. 5% tannic acid solution is added to drug extract. Buff color precipitate is formed. This shows the presence of alkaloid. Okay, students, in the next class, we will discuss about the structural elucidation of alkaloids.